Okay, so last time we were talking about multiplying polynomials. So this time we want to add a little bit to that and talk about some special products. Product means multiply, right? So special products, and these are with two binomials. Okay, so let's multiply this out and see what we get. 3m times 3m, 9m squared. 3m times negative 8n, negative 24mn. Now that I've multiplied this term by everything in the second binomial, move to this term. 8n times 3m is positive 24mn, and 8n times negative 8n is negative 64n squared. And when we're combining our like terms, look what happens. We have negative 24mn plus 24mn. So those middle terms disappear, leaving me with just 9m squared minus 64n squared. Okay, so look what that is. And pay attention to what the binomials look like. Everything is exactly the same. The only difference is the sign in the middle is opposite. One's a plus, one's a minus. So if I recognize that, this is something called the difference of squares. They say of two terms, but the difference of squares. Okay, there's a minus, so it's a difference, and everything's a square. Look, 9 is 3 squared, of course, m squared. 64 is 8 squared, and then n squared. So if I recognize that, all I have to do to multiply these together is square the first term, 3m times 3m. It's always a minus, and square the second term, 64n squared. Okay, so on this one, look, it's still the difference of two terms. It'll wind up being the difference of squares. If everything is exactly the same, the only thing that's different is the sign in the middle, and one's a plus and one's a minus, and it doesn't matter the order. Then to multiply it out, I get a shortcut. Okay, 5p times 5p, 25p squared. 1 times 1 is 1, and it's always a minus in between them. A lot handier than having to do my distributive property. Okay, one last time. Look what this would be. 25p squared minus 5p plus 5p. And then minus 1. Those add to 0. Okay, so we have these kind of special products and these kind. So it can either be written as this, as a binomial all squared, or if it's written out like we're used to seeing them, what I need to recognize is that, hey, these binomials are exactly the same. Those two we just looked at, everything was the same, but one had a plus and one had a minus. If they are exactly the same, or if it's written with a square, now be careful. Remember, we did not have any exponent rules where there was a plus involved. Everything only multiply and divide. So if I multiply this out, okay, 4x times 4x, 16x squared. 4x times 5 plus 20x, 5 times 4x plus 20x, and then 5 times 5 plus 25. So this one, instead of the two terms in the middle canceling out and adding to 0, they double, right? Because I'm going to have a 4x times 5 and a 5 times 4x. So I'm going to get 2 of these terms in the middle. 16x squared plus 40x plus 25. So a shortcut for multiplying this out would be, if I recognize the format, right? If it's the exact same terms in each binomial, if everything's identical, or it could be written as a binomial all squared, I can square the first term, okay, and square the last term. And by the way, that will always be a plus. And then for the middle, I need to multiply the 2 terms together. So that would be 20x and double it. Match that sign. Oh, I didn't double. And double it. 20x doubled. And look, same thing. Okay, so my shortcut here tells me, hey, this is a binomial being squared, so I can square that first term, 6x times 6x. I can square that last term, 2y times 2y, and it's always a plus, because even if this is negative, a negative times a negative, that's always a plus. Multiply the 2 terms together, 6x times negative 2y, or I'm just going to match that sign, so I could say 2y, 12xy, and double it. 12 and 12 is 24xy, and you match that sign. So once again, it just allows me to multiply these certain kinds of binomials out in one step, instead of having, in this case, 3 separate steps to get there. Okay, so they're going to sum that up for us now, I believe. The square of a binomial. So if you've got a binomial all squared, or if you've got the same thing written twice, which would mean you're squaring it, you're multiplying the same thing times itself. You square the first one, you square the last one, and the middle is 2 times these things multiplied together. And notice, this is always a plus, but this first sign matches whatever's in your binomial. Now be careful. This is not a squared plus b squared. We do not have an exponent rule that says we can distribute that over a plus. We just got through multiplying it out and seeing that this is not the same. We've got this middle term in here. Whoops. We've got this middle term in there. Okay. And if everything's the same but the signs are different, one's a plus and one's a minus, you square the first term, square the second one, and the middle term disappears and you just have a minus there. Another word for these things are conjugates. So x plus 2 and x minus 2 are called conjugates if everything's exactly the same but the sign in the middle is different. And so we might call those conjugates a little bit later. Okay, so I want to recognize that, oh hey, I know how this binomial, it's a perfect square. I know how it multiplies out. I cannot distribute here first. Remember, you got to do exponents before multiplication, so I got to take care of this first. So it's 2x, and then multiply these 2 things first. Square the first one. Multiply the 2 terms together, so I would have negative 3 times x. If I double that, I've got negative 6 times x, and then square the last one. Now I can distribute the 2x through and finish this problem, giving us 2x cubed minus 12x squared plus 18x. Okay, this one's the difference of squares. So if the signs are different You square the first one. 2x times 2x is 4x squared. You square the last one, and you always have a minus in the middle. Now, let me make one comment. Technically, if you're careful about this up here, and you know to rewrite it like this, you can always get your answer by our regular distributive property that we talked about in the last video, right? But this is going to be really useful to us when we get to college algebra, and it's going to help us in factoring, where in the last section we're going to go from the multiplied out polynomial to these kinds of forms. So I want to change this to look like this. We'll be going backwards. And if I know these shortcuts, it helps me with that factoring. Okay, one more. It also helps me with things like this where my exponent's bigger than 2. Remember, I could rewrite this like this, right? Here's one of them. Here's two of them, right? The base is the same, so I could put them together with that exponent. But I've got a shortcut to multiplying that out. Okay, square the first term. Multiply everything together, negative 28s, and double it. 28 and 28 is 56. And then square the last term. Okay, so I've done this part. Now I've got to distribute here. 7 times 49. Let's see, what's that? 7 times 9 is 63. 343. 7 times negative 56. 392s. If you need to go over and do your multiplication, go over and do that. 7 times 14s squared plus 98s squared. And then move to the next term. Negative 4s times 49, so negative 196s plus 224s squared. And finally, I guess didn't leave myself enough room, so I'm going to put it right here. Minus 56s squared. S cubed, how about? Okay, 343 minus 392s, s squared, s squared, s cubed. Okay, so negative 56s cubed here's an s squared and here's an s squared. So plus 322s squared. Here's just an s, here's just an s. They're both negative, so really I'm going to add them and keep that sign in front of the bigger one. So what's this? 588s. And then finally, plus 343. So these numbers got a little nasty on this one that they gave us. But remember our process here. And if I had a higher exponent, right, then I would make it 7 minus 4s squared times 7 minus 4s squared. And I could use my shortcut on this one and this one. But then I'd have to do that long distributive property. Okay, so special products.